So we're going to look at what happens when we make a solution. What you're seeing on the screen right now is water. You can see that the big red part, that's supposed to represent the oxygen and kind of the space that its electrons are taken up. And then the two little white sections on either side are supposed to represent the hydrogens. And I can throw the partial charges on it so you can see like the oxygen side is the side with the lone pairs and everything over there is negative. And then you can kind of see the positives on the hydrogens if you need help kind of identifying which ones they are. So we've got two different kinds of conditions that are going on when things dissolve in water. So on the left-hand side is salt, NaCl, it's like table salt. And you kind of probably already know it comes in like a cube-like shape. This diagram doesn't really represent the cube shape, but it comes like stuck together. Like NaCl is one unit, but it usually comes as like this big cube shape. I'm going to stick this in the water, and what's going to happen is that the chlorine is going to get attracted to those positive hydrogens, and then the sodium, which is positive, is going to get attracted to the negative side. So when we put it in, there we go. And notice that everything and everyone is still moving. But you should start to see, and of course it's not perfect, but like the sodium, like on the top left, it's mostly red parts that are touching the sodium. And then on the chlorine up on the top right, you can kind of see it. It's sliding away. But anyways, you can see that it had a little bit of the negative side on that one. So that is one thing that happens. If it happens that the forces that are holding the Na and the Cl together right here in the solid phase are weaker than the forces attracting it to the water, it will dissolve. And not only will it dissolve, but the positive ions will be attracted to those different dipoles in the water. They call that ion dipole. And that's what happens when you make a solution. So the other thing that can happen is on the right we have sugar, and we haven't talked about sugar very much, but sugar has an OH group on it. Besides that, it's a whole lot of carbons and hydrogens and oxygens, and it doesn't have that positive negative placing to fall apart like the salt does, but it does have these OH groups. That's what the on the edge of all of it, the big ball with the little ball on it, that's what that is. So they have OH groups, and if you remember, water likes to hydrogen bond. And this simulation doesn't actually show the hydrogen bonding, but that is what's happening, is that the water, in which you should kind of see, again, it's a simulation, is that the negative side, the red side of the water, should be attracted to those little tiny, yellow circle hydrogens on the edges of the sugar. So in this case, it's dissolving because it's attracted to the water forces. Now I'm going to come back and do the micro view. And if I go to this one, this is the sodium chloride. So I'm going to put some sodium chloride in. These kind of do a better job of kind of looking a little bit more cube-like. And you can see now they're all dissolving in the water, moving around. But what we know what's really happening is that it's getting attracted to the partial positives and negatives on the water. Now, there is an additional thing that will happen with this. So I'm going to reset it. And we will do the sugar again. So you can see here it's got all those pieces, and as they're floating around, they're not at the bottom as though they're not dissolved. They're dissolved. They're just interested in the water and the sides of the water. So it's two different reasons for why they're doing this. So I want to show you what happens when you hook up some electricity. So right here we have pure water. There's nothing in it, and you'll notice that our light bulb is not lighting up at all. And that's because there's no positive or negative charges. Well, there's a partial positive and partial negative, but I mean, it is just the tiniest percentage of water that'll break apart into ions, just the tiniest of tiny percentages. And so you're noticing this isn't setting up the light bulb. Now, when we put salt in, I'm going to put a whole lot of salt, this NaCl, we've got those positive and negative charges. And so all we need to make a light bulb light up or to get electrocuted is to have a reason for the electrons that are coming from either the battery or they're coming from, lightning or whatever they're coming from, your electric socket. The electrons just need to have a reason to flow. And so when you're putting that positive, negative, and the salt in, and it falls apart into those different charges, now all of a sudden your electrons can be repelled from the positive sodiums and attracted to the negative chlorines. In contrast, if I give it sugar and I set up the conductivity, Remember, the sugar isn't dissolving because it's attracted to the poles of the water per se. It's doing hydrogen bonding, yeah, but it's not trying to split apart. And so because of that, we don't have anything going on with our light bulb right there. So you can see that there's a difference. And I just want to point out that the more concentrated it is, you can see our light bulb is growing stronger and stronger. And if I evaporate the water, see, it gets even stronger. So the more concentrated it is. So the strong electrolyte is something that will break apart in water. A non-electrolyte is something that's got like lots of hydrogens and oxygens, and it won't split apart in water. And then you could also have a weak electrolyte. And a weak electrolyte is something that only kind of splits apart in water some of the time. And I have a similar simulation, but this one shows it better. So in this case, I have something that is slightly soluble. So you can see some of them are falling apart and some of them aren't. So you can kind of see like some of them are sitting on the bottom. And if you watch it carefully, like it'll rejoin and unjoin. And so in this case, it's just slightly soluble, and some of it just won't dissolve in. That'll just look like a big pile of, if this were a white salt, it'd look like a big pile of white at the bottom. So when you set a light bulb up with this, it very, very faintly can glow because some of the ions are dissolving, but not all of them, because this is not very concentrated.